All right, finally, good gracious. I apologize for that. Just to show you guys what I see. Okay, so as you're working through your assignments and everything else, hopefully everything's working out. What I look at are the most missed questions. And so it shows me that number 11 was the most missed, and 52% got it correct on the first try, which it could be one of any one of those deals. And a lot of times I'll look at that question, and believe it or not, a lot of times I'll miss that question. It's understandable that you're not going to have 100% every single time, but I'm always making sure mostly that it's not a big concept, right? So I kind of look at that. I can go down through here with all students, and I can see each student, how long they spent, what percent they got right first try, just things like that. And I'm just looking for anything that stands out. Okay, come on in. Anything that stands out that might be something else. Okay, so just kind of see what I see. Nothing stood out last night. I don't think anything's going to stand out tonight, but just kind of understand all that stuff, right? As class progresses or as the bell rings, that assignment closes, and you should have another one, or it won't be open yet, but you'll have another one that will open. It says late. If you ever want to go back and look at the assignment, of course, your answers will not be there, but I don't look at the late. I look at this grade first, and then I look at this grade, and if this grade's higher than this grade, I'll put it in, but if this grade's lower, I don't put it in. So you don't have to do the late assignment if you did the other. And the only difference between the late one and that one is the late one's worth 4 points and the regular one's worth 5 points. Yeah, you okay with that? So there's a couple 0%, but we had some class movement, and it didn't. If I move you classes, it doesn't keep up with your grade. So just communicate with me on that. The biggest questions, and those are the ones 7, 8, and 9. Those are multiple choice questions. Those are the type of questions you're going to see on your test. So really focus on those multiple choice questions at the end, and not necessarily look to see which one's right, but maybe why the other 3 are wrong. Okay, so just kind of be aware of that. All the other stuff is kind of knowledge based and just testing your, just reaffirming your knowledge. And then this down here are, do you understand? So just kind of make sure you follow that along. Okay. As we get closer to test time, I'll start looking to see some free response type questions of what you're going to see on the exam. Okay. All right. Everybody okay with Achieve? Got a couple brand new ones, but you'll slowly catch up to all that. So, Jamal? No. Completely new? As of? Monday. Wow. Howard, welcome. Yesterday. Okay. Welcome. You weren't even on my roll yet.
I changed all of it on Friday. It starts Monday.
Just looked, I thought, but maybe I did. Whatever. Welcome. So I need to get you a note packet. All right, everybody else good? Happy, joy? Any questions over that assignment? That's something that you got lost with? Hit me. Used to a long time ago, I could. Helped everybody else. What's that say? 1. No. Oh. 4? Yes. His question was, can you go over 4? Both times. So I went over 4. Okay. Any other questions? Yes, sir. Yeah.
Can you go over 8?
Can I go? Any other questions?
Can you explain how you find the answer?
Oh, yeah, probably. Dairy cows. Okay, so this is one of those that I'm going to imagine was highly up there missed just because you have to drop some things in there and there's just way too many opportunities to miss one little bitty thing, and that counts it as a miss if you just miss one little bitty thing, right? So a dairy farmer has 1,000 dairy cows. That's a lot. I grew up on a dairy farm. We had like 100. They want to estimate the minimum daily milk production for dairy cows in the herd. 20 randomly chosen dairy cows. The minimum was 6.3. So picture this, you got 1,000 dairy cows, and they're going to randomly select 20 of those dairy cows and measure how much milk they produce. And the smallest that those 20 produced was 6.3. That's probably not the smallest out of 1,000 of them, but the smallest one of them was 6.3. The largest one was something else. And you got an average of those cats. And the average of those cats may or may not be the average of the entire population. We hope it's close. Again, this is like big picture type stuff, but we'll figure all that out throughout this entire year. Identify the population. Population is 1,000 dairy cows. The parameter. The parameter is the number, the number we're looking for the average or for the population. And so the parameter for the population is the minimum daily output, minimum daily production for all the dairy cows. So minimum daily milk production for the 1,000 dairies. That should be that bad boy right there. Is it going to let me do this? No. I don't know why, but it won't. No. Okay. The sample, and the sample are those 20 dairy cows. And then the statistic in that setting was the 6.3, the smallest number in those 20 dairy cows. Does that help you?
Yes.
Okay, what else?
Can you go over the answer for 7?
7.
We were just on it.
I was. Oh, it was the top one. Oh, the multiple choice one. Woo-hoo-hoo-hoo-hoo-hoo.
Specifically, like the home address. Maybe
Is that it? Oh, that wasn't this one?
8. It was the same prompt, but
You okay with that one? That one good?
would you include home address in as one of the variables?
I don't think so. I don't know. I didn't read the question, but I'm just going off of what I'm thinking. I don't think I could figure out like the average of a home address. Like I think the address is like the units, like the observational unit. That's what I'm using to gather the information from.
Like you could assume, like let's say it's labeled like home 1, home 2, home 3, and then the address is the variable of that.
Yeah, I just don't know where the address would help me dissect anything. Yeah, hypothetically, yes. Hypothetically, yes. Yes, if you were listing them 1, 2, 3, 4, and you got the address, then that would be the variable from it. Good, great question. Drew, did you need number 8 or? Oh, okay. I don't have any idea. 7 variables, is that what it was? 3 categorical. That's the trick one, right? So categorical, primary building material, categorical, square footage is number, has a pool, that's categorical. Huh? Oh, number of bedrooms. Thank you. So we're back down to 3. Age, sales. Yeah. Yeah, it's kind of, I like what you're saying, the address, but the physical address of the home, Like if I got each one of your addresses from home, all that does is tell me where you live. I don't think it helps me much of anything other than maybe location, but I don't think the actual address doesn't. Yeah. Okay, that's cool. I think I probably would rather do like Southwest, Central, Northwest, and just do that as opposed to address to put you in a category. Yay. Happy, happy, joy, joy. What else? Anything? So again, bear in mind that those, when it says, it's typically the last 3 or 4 or 5 questions. MCQ. Those are the type of questions you're going to see on your test. Okay, those are, and I'm changing them. I'm having to change a little bit of me because, like I said, 19 years, guys, it's been 5 choices, and they're switching it to 4 choices. I think what they're doing is just removing the one that was obviously wrong anyway. Because in the 5 choices, one of them was obviously wrong. There are no variables in this category. Okay? Beautiful. I'm listening to Miss Grisham talk over there. Miss Grisham sat right about there. We had different desks. I had her for 2 classes. And now she's over there teaching. I'm getting old. Beautiful. I went over 4 and 8 again. Hence, when he first started, I started looking like, and I said used to. Actually, I never could get over that 4, but all right. What's the other one? Oh, the big one is, can you do number 6? And I'll go, yep. And I'll just sit there. My Cal teacher in college, that's what, can you do number 8? He goes, yep. He just sit there. He goes, I can do all of them. Can you show us how to do it? He goes, oh. Boom. So we are on B. I'm embarrassed to teach you guys B because it might be the easiest lesson we will ever do. And maybe not. I'm learning this with you guys. Yes, sir. Oh, you need notes. There's one right there. Careful. Good. That's all right. Uh-oh. Heck, I'm dropping stuff. At the beginning of every slideshow, we'll have our learning targets. So what we will learn. And at the end of every slideshow, we're going to have what we hope you learned. So I'm going to give you 3 or 4 bullets. Typically, those are our main topics we got to make sure we understand by the end of it, right? At last, or in 1A, it was categorical and quantitative and all those things, right? Observational units and variables, okay? So we're going to have 3 up here. Today, it's going to be talking about displaying and describing categorical data. Displaying and graphing, or describing, displaying is graphing, describing categorical data. 1C, 1D, 1E is going to be displaying and describing numerical or quantitative Okay, just kind of, this one's easy. There's only two kinds of graphs you can use, and describing it is pretty easy to describe it. It's, you're going to talk about what you see. So I guess I need a button. I knew I was missing something in my hand. Got two things in my hand. I don't need either one of them. There, button. Well, let's turn it on maybe. Zzz, zzz. Make and interpret a frequency table or relative frequency table. So frequency and relative frequency, that's going to be our first topic. That's probably going to be a little bit new to you word-wise. Make and interpret bar charts, pie charts. And I might call it a bar graph or a pie graph. But either way you want to call that, okay? That one's probably not new to you. You probably know everything about what you need to know there. Compare distributions of categorical data. You probably can do that, but I want to make sure that you can do it according with AP. And then identify what makes some of the graphs in categorical data misleading. Okay? Now, let me preface this lesson by this. On the AP exam, the entire thing's digital. So you're going to be typing a bunch of stuff. I doubt you're going to have to make a graph because I don't know how you can make it by graphing. Plus, you making a graph, I don't think says anything about your statistical knowledge. I mean, it says something about your artist of knowledge, but I can ask you questions about the graph that test your statistical knowledge. What should go on the bottom of this graph? That kind of, I don't know what all else. What's misleading about this graph? Which category? Is it categorical data or numerical data? Just types of questions that I can ask you about the graph without you having to make it that test your statistical knowledge. Preface all that. Good? Click. Click. A variable generated, take it, we talked about a variable already. The distribution, so this is the word we're going to make sure you understand. Again, I don't like the definition. I think the definition is a little bit more confusing than actually what a distribution is. But a distribution, I kind of pick, is a picture, it's a graph. It's a distribution. How are those variables distributed? Distribution of a variable tells us what values the variable takes. All right, so we had those 20 cows, and we got the amount of milk each cow produced. And if we put that on a picture, if we got those values, that would be a distribution. It would be a distribution of the minimum amount. Was it the minimum amount? I guess the amount of milk that cows produced. That would be a distribution. It's a variable that tells us, of a variable tells us what value the variable takes and how often it takes it. Typically, this is a graph. Typically, a distribution is a graph. It could be a table. It could be a frequency table, of which we're getting ready to talk about. It could be a relative frequency table, which we're getting ready to talk about. But most of the time, that is a graph. Because numerical, that's the only way is with a graph. You can't make a table from categorical, okay? I will promise you, I at least on my test, but more than likely on the AP exam, it's going to say the words, describe the distribution. That's what it's going to say. Describe the distribution. It's going to be your job to decide on if it's categorical, and if it's categorical, how you describe it, or if it's quantitative. And if it's quantitative, then you have to describe it a different way. Okay? So distribution. It's a picture of the data. It's just telling me what the data says. It's telling me what the data says. Everybody okay with that definition? Clicky, click, 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 click. We already talked about this. We already talked about this. I don't know why I left it on there. Frequency table. I need to do a better job on these. I went through them once or twice already. And frequency table. A frequency table is just that. How frequent does that variable occur? I mean, I'm almost better off giving you an example of a frequency table as opposed to giving you the definition. Okay? The definition of a frequency table is almost a picture of it rather than me trying to explain it. Shows the number of observational units and the value of that variable. Here we go. here's what you do need to know. The relative frequency changes these to percentages, proportions or percentages, proportion or percentages, okay? So that's what you need to make sure you know. Whenever you see that word relative, we're talking about percentages. We're talking about percentages. Frequency is just how frequent it occurs. That's just an integer. That's an integer. 1, 2, 3, 4, 5, 6, 7. Relative frequency changes the 1, 2, 3, 4 into percentages. I'm looking around for pencils. I don't see. Mr. Whoever asked his students, I need to say me, I guess, which fast food restaurant has the best chicken sandwich? There's their answers. Make a frequency table. So if I'm going to make a frequency table of that, I'm going to pick, it doesn't matter. I'm going to start with Chick-fil-A. Whoop, I need to put restaurant up top. Restaurant, line, frequency. 1, 2, 3, 4, 5. Yay. Popeyes. 1, 2, yay. Yay. Popeyes is first on this one. Who cares? There's 14 Popeyes. Shake Shack, there's 6. I guess Chick-fil-A's next at 5, so I guess they put them in order. KFC 2, they don't, it doesn't matter how you put them though. There's no right or wrong reason. It's the variable and how often it takes it. How frequent does this one occur? And then for some reason they put the total down here at the bottom. And you don't have to put the total. You don't have to put the total. I think they did that to help you make a relative frequency, because you have to know the total in order to do a relative frequency. Because all I'm going to do for the relative frequency is turn those into percentages. And when they ask about percentages, guys, you actually, in AP statistics, you can do one of 3 things, and they'll count all 3 of them. You can use a fraction, you can use a decimal, or you can use a percentage. They don't care. They don't care. I typically use a decimal because decimals don't reduce. Decimals help me a little bit more. 0.67 helps me a lot more than 2/3. It just does. But they don't care. And they don't care if you don't reduce a decimal, and they don't care how many decimal places you take things out to. I typically take it out at least 1, sometimes 2 decimal places. But I say that, sometimes you might get an answer of 0.00004. Well, you don't want to take that out to 1 or 2 decimal places. You want to take that out until you get to the 4. Y'all kind of follow what I'm saying? Because if you put 0, they're going to count you wrong, because that 0.0004 is different than 0, especially in a statistics class. Pre-cal, it wasn't. If it's 0.00004, we said 0. And you can say almost 0. Y'all okay with that mathematical notation? Approximately, about, close. It's really close to 0 if you want to write it. But by then you could have put 0.00004. Just trying to explain to you. Okay, y'all good? So Popeyes is 4 out of 27, 14 out of 27, or 0.519, or 51.9%. If you wanted to put 0.52, they're okay with that. I mean, if you put 4.6, you're going to be wrong. 5.1, they'd count. 5.2, they'd count. That's probably about it. I don't, but why you would put something else, I have no idea. Yes, sir.
So on the AP exam, we put the relative and did like a decimal or percent.
I typically put a decimal, but they don't care. Everybody else okay? So let me pump out real quick. Shake Shack is 0.222. Chick-fil-A is 0.158. KFC is 0.074. Okay. Let me show you something on your calculators. I should have opened that first thing this morning too. I got to start opening this stuff up. I had to renew my teacher license today. And I spent almost an hour and a half. Still not done trying to do that. It's not a quickly like renew. You got to pay 4 different people. You got to go get fingerprinted. I had a top secret security clearance in the United States Navy, and I still got to get I still got to get whatever. Top secret Umbra, which actually I shouldn't be saying that because that's actually secret. But whatever. I don't know what Umbra meant, but it meant I had a pretty high one. It sounds a lot better than it really was. Finally, here we are. I'm going to teach a whole lot about this calculator this year. Remember, Desmos can be used. Any other type of calculator can be used. If you need more help on something with a calculator, like a calculator that you can't help, just let me know and I'll help you with it. But I'm one of those that I think you're better off finding out how to do things by yourself. You're more likely to remember how to do it. But most of this stuff you already know. You already know about sine, cosine, and tangent. We're not going to use that in this class, right? The 1, 2, 3, 4, 5, 6, 7, 8, 9, you'll use a lot. You'll use the operations over here a lot. But there's this one button right here called stat that you're going to use a whole bunch too. Imagine that. And you probably have used it quite a bit. I know you cats in pre-cal last year used it, but if you've had other classes, you probably have used it. And you have 3 different options on stat, edit, calculate, and tests. And that test, we're going to wear out the second semester. We're going to wear that bad boy out. But right now, we're not. We don't need to even calculate anything. All I want to talk about is the edit. And of course, the edit puts the data in there. So you should have, you guys with TIs, which most of you guys do, L1, L2, L3, L4, L5, and L6. And if you don't have L1, L2, L3, L4, L5, L6, I'm just throwing some stuff in here real quick. Because you went up here instead of hitting clear or you did something else. Oh, gosh. I'm so patient. You hit delete, which removes L2. And so you went over here one time and you deleted that one, and now it looks all jacked up and you don't even know where everything is, right? And so then you go second L1. And you didn't even delete it. You just kind of hit it. And now it's really jacked up because it says L5 still. So that's when you go stat and you set up editor. Whenever those things are jacked up, you just set up editor and you hit enter and it says done. Notice I don't toggle a whole lot. I hit the buttons. And then if I hit stat and edit, now there's your L1, L2, L3, L4, L5. Okay? And in L1, you could put those frequencies. I don't remember what they were and who cares. 5, 14, 6, 5, 2. I don't know, I'm just making all that up. I don't want to divide all those by 14, 27. I don't want to divide all those by 27, although I could. But rather than divide all those by 27, I can do it with one easy step. It knows how to put it up at the top. So that's like a math, it's like an Excel or Google. You can put a formula up there. And so the formula I want to put is I want to take all these numbers, which those numbers are L1. So second, L1, L2, L3, L4, L5, and L6. I want to take L1 and I want to divide it by, what did I say, 27? And that will change them all to decimal for you pretty quickly. I don't know how helpful that is to you, but I'm kind of a nerd. And if I could speed up my process a little bit, by the time you guys did all that stuff, you probably could have divided it. But just understand that's there. Good enough. Second stat, that brings up all your lists. There's the operations of all your lists. This is sorted ascending, sorted descending. But notice one of those is, oh, this is math. Sum. Guess what? If I want the sum of L2, I better get 1 because that was all of them. All right, done with that for today. Clicky. Oh, I got too many windows open. Here, apply, slideshow. All right. Click. Boom, 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 boom. Okay, relative percentages. Fraction, percent, I'm sorry, fraction, decimal percent, AP won't care. AP won't care. How many decimals? AP won't care. Get 3 of them right and get 1 of them wrong, you better hope it's not the one that they're grading. Do these data support the claim that a majority, what does majority mean? More than 50%. The majority of Mr. Oster's students think that Popeyes has the best chicken sandwich. And then we have to justify our answer. Because I promise you, if you just put yes on the answer, you're probably not going to get anything. You might get the yes. Justify your answer. And none of you guys are going to justify it correctly at first because I haven't taught you how to justify things correctly. Yes, because Popeyes is over 50%. Let me even do it worse than that. Yes, because it is over 50%. No points. We don't use it's. We don't use because. Yes, Popeyes is over 50%. Actually, yes, Popeyes is 52%, which is over 50%. Something like that. They're going to write a novel. I don't expect you guys to write novels. If you write novels, you're not going to get your tests graded. Yes, because 14 out of 21, which is 0.519, which is 51.9% of the students in the class said that Popeyes has the best chicken sandwich, which is the majority. Beautiful. Too beautiful. But covers it. What's your job? Hit the rubric. Hit the rubric. Don't write too much where you say something wrong. That's going to be my hint. Don't write too much to where you say something wrong, because if you say something wrong, you're going to get dinged. What if I leave something off? If you leave something off, I can't prove what you do or what you don't know. But if you put something wrong, I can prove that you don't know what you're talking about. Y'all good with all that statements? So that's way too much. Yes, they answered Popeyes restaurant 52% of the time, which is more than 50%. I bet that will be plenty. I bet that would be plenty. What if I don't say it, which is more than 50%? Because it's obvious that it's over 50%. I don't know that you know that the majority means it has to be over 50%. As common sense as that is, I don't know for a fact what the rubric will say, though. I don't know if that has to be part of it or not. I think it should be. I think it should be. A lot of times I used to suggest, don't necessarily tell me why that's right, but tell me why the other ones are wrong. Whereas the other 1, 2, 3 chicken places are under 50%. But that's not what their question was. Everybody okay? I'm just trying to help you out a little bit AP-wise. So yes, well, that answered this question, but it didn't answer that part. And that part's graded a whole lot harder than this part. What if I don't put yes? You didn't answer the question. If it just said Popeyes is over 51% or over 50%, that probably is not going to cut it either. You got to have a yes or a no. Y'all good with all that? Good? Happy? Boom, boom. Note that frequencies and relative frequencies are not data. That's not data. It's a summation of data, but it's not data in itself, okay? The data was the list of all the answers that they got. That's the data. This and this is not data. It's a picture of the data, okay? The frequency tables and relative frequencies summarize the data by telling us how many or what proportion of the restaurants chosen have the best chicken sandwich by that class. Okay, just kind of recognize that. So if you went back here and said, yes, because the data shows that Popeye, you're going to get dinged because you just lied. That's not the data. Okay? Oh my gosh, I wouldn't have thought of that. That's why it's not easy to get 100s on an AP exam. Click, click, click. Back? Good. That's all right. My fault. I normally look at pencils. I see a lot of pencils going, I don't go, but I clicked one too many. Woohoo! If I do it too close to the camera, it gets on camera. This is not on camera. Okay, clicky, click, click. Displaying categorical. There's two ways to display it. Two ways. Bar chart is one of them, or a bar graph. I don't care which one you call it. And I'm going to go through a whole lengthy process of what a bar chart is, a bar graph, and you really already know what a bar graph is. You do, I hope. A frequency table, relative frequency, can be started with a bar graph, bar chart. I don't care which way you call it, okay? But it's just that. It's a graph with a bunch of bars, okay? A bar chart. It's a graph with a bunch of bars. So I'm going to give you a couple of hints on those bars. The bars are separated. They're not touching. Those bars should not touch. They're separated because it's categorical data. They're separated by a space, okay? I don't know. You got to, again, as you got pictures of bar graphs, don't take too much out of this. You need to know that a bar graph can be used for categorical data. The other one is a pie chart. Those are the only two ways you can graph it. Could be a multiple choice question. Which of the following would you use or could you use to graph categorical data? You better hope that's a question because that one's pretty easy. It's either going to be bar graph, or pie chart. Click, click, categorical, categorical, categorical. There's a bar graph, right? You got in person, you got internet, you got phone, you got social media, you got text. It's a picture of this data. This is a relative frequency. You can put the relative or you can put the frequency. Either one. I like to put the relative because I can put 1 at the top, I can put 0.5 in the middle, I can put 0.25, I can put 0.75, and I'm pretty much done. If I put the numbers on there, sometimes I have to, like if it's 276, okay, I guess I'll put 300 and 150 and yeah. Y'all okay with all I'm saying? Either way, doesn't matter. Percentage or relative. It has to, let me rephrase that. Yes. It has to start at 0. It's got to start at 0. If you don't start at 0, that's going to be a misleading graph. We'll show you that in a little bit. Another thing that's misleading is if it starts at 0 and this is 10, the next one better be 20. If it goes from 0 to 20, the next one better be 40. If it goes 0 to 50, the next one better be 100. And if it's not, it's going to be a misleading graph. So just be aware of those things. A lot of people always picture bar graphs like this. They don't have, they could be turned sideways. So we could go out here and we could make the bars this way. Just understand that also. Okay, they don't have to be, the categories don't have to be on the bottom. They can be on the side. Y'all okay with the bar graph? Good? Click. I don't want to talk a whole lot about it. Why do we make them? Why do we make them? Because they give us a picture really quickly. Like this, you guys are smart. It's not going to take a whole lot to realize that 24 is the biggest one. But over there, I can easily see that text messaging is by far the most. It's a whole lot easier to see it. And if there were 40 categories, it's a whole lot easier to see it with a graph than it is with a table. So we look at a picture of it to tell us that, okay? Not only can we see it's the highest, we can see what it's like almost twice as high as the next. And again, I can do that over here at 12 and 24. In fact, you can see it's exactly half, but we don't like to use concrete words. We've played a total of 55 Olympic Games since 1896. The Summer and Winter Olympic Games are usually held every 4 years. I don't think it's usually, but they are held every 4 years. However, in World War I and World War II, they did not hold them. The frequency table summarizes the distribution of the region of the world's events. So that's a frequency table. We can turn that into a relative frequency table pretty easily if we needed to. Frequency table, make a relative frequency table. So here we would make a relative frequency table. Just follow along with all this stuff. We've already practiced this. I don't think you need to practice that a whole lot more. And then there would be the graph. And so it doesn't matter what order you decide to put those bottom numbers in or the categories. They decided to put them in alphabetical order. Who cares? You can put them however you want. And then they put the relative on this side over here. They didn't go all the way to 1 because you don't have to. They broke it up a little bit more, and then they put bars for each one. Okay, easy peasy, lemon squeezy. Don't make this that difficult. You're not going to have to make one on the AP exam. You're going to have to describe it. Or what would the height of North America be? And you would get that from here. But you would have to look over here to see if it was relative frequency or frequencies. Good enough of that? Click. Describe what you see. This is something you would have to do on a test. And if you say the second bar is the tallest, probably no points. Even though that's a true statement, no points, because who says that Europe has to be the second bar? It starts low, goes high, then comes back down low, and then goes really, really low. No, can't say that. Okay? Europe, by far, has held the most Olympic Games. Ooh, that's pretty good. Europe is the tallest. That's not very good. Be specific in context. That thing's telling you a story. You tell me what the story is. Europe has held the most Olympic Games since whatever, if you really wanted to. The next country being North America, with Asia being really close. In fact, they are about half. Now you're starting to go, oh my gosh, how much do I really need to write? I don't think I'd write this much. I don't think I'd even put the numbers in there, although it's not wrong to put them in there. I don't think I would even put them in there, because if you wrote one of the numbers wrong, they're going to ding you. The modern Olympic Games context have been hosted more often in Europe, which has hosted more than twice as much as the next most, which is North America. Asia has hosted only that of the modern Olympic, so they're kind of just listing it now. But my hint to you guys is this. You need to hit 4 things. I always talk about the tallest one, I talk about the shortest one, and then I talk about something else. Something else. North America is half of Europe. And then the 4th thing is you have to be in the context of the question. Don't say it. Don't say anything generic stuff. Talk about the actual countries. Talk about the Olympics. Talk about the numbers. If you can hit 4 things, typically you got the rubric. What if I mention 5? So you probably hit the rubric. What if I mention 6? You probably hit the rubric. What if I hit 3? You may or may not have hit the rubric. What if I hit 12 of them? You better not lie. Because if you lie, you're going to miss something. Well, I hit the rubric. Yeah, but you also don't know what you're talking about. Everybody okay with my wording and what I'm trying to help you out with? Try to get your points. Very seldom have they said, describe a distribution and it be categorical. Most time it's numerical. The question I graded 2 years ago was a numerical. And you have to say certain things about a numerical. It's 4 things also. Another type is a pie chart. We used to never deal with pie charts very much because they get a little messy. I think this is a whole lot messier than a bar graph. It's not as easy to see the categories. It's really hard to see that this category, if I didn't put the numbers in there, I think it'd be really hard for me to tell that this one is bigger than this one. I can tell it's bigger than this one, but it just kind of understand that stuff. I think you guys can read a pie chart. I think you can read a pie chart. It's broken up into the biggest deal about this is you have to have 100% of the data. So more times than not, you have a other, right? They don't want to list them all, so they'll just say anything else. But in a pie chart, it has to add up to 100%. Would I put that on here somewhere? There it is. You got to have all of them. You got to have all in a pie chart. Bar graph, you don't have to have all. These computers are getting ready to get you in trouble. I'm just speaking from experience. About 3 years of this, the cats that had computers open typically don't do well. There are exceptions. There are always exceptions. Y'all okay? Good. Comparing distributions of categorical data, same thing, right? Use a bar chart, a pie chart. So comparing distributions. So you may have 2 bar graphs. And if you're going to compare those, okay? They may be side by side. You may see a bar graph of females and a bar graph of males or whatever. Whenever you compare high, low, something else, context, just make sure you compare. This word right here, where is it at? Where'd it go? Oh, this one right here, I guess. Just make sure you compare. Higher, lower, about the same. Okay. Again, I think I'm spending way too much time on categorical data that I don't think you're going to see. Here's 2 of them. Pew Research, random sample of U.S. adults, why they thought it was best, or what they thought was the best age for a U.S. president. Kind of interesting. What they thought was the best age for a U.S. president. The side-by-side bar graph shows we have 18 to 29-year-olds and we have 60 to 69-year-olds. Here's the 18 to 29, here's the 60 to 69, and they're going to need to compare. Both groups think that the 50s would be the best age for a president. However, the 60 to 69-year-old think a president should be older than 50, whereas a 28 or 18 to 29 think it should be younger than 50. Because the next highest block for the 18 to 29 is 40, whereas the next highest, not this 40, I'm sorry, this 40 here. The next highest over there is 60. Just talk about it. You're just trying to hit the rubric. And typically, if you talk about 4 things, you're okay. There's only 4 bars there. We'll just talk about all 4 bars. If you write this much right here, we're going to have issues. Okay? We're going to have issues. Because I have to look for something wrong in here. You probably hit the whole rubric, but now I got to figure out if you just said something wrong. If I'm at the AP grading, if I'm at Tampa, Florida, which is where they put me for AP grading, which I'm more concerned about going to the beach than I am grading your paper. And if I have to spend this long looking at this to try to find something wrong, I'm going to try to find something wrong. Y'all follow what I'm saying? Y'all good? I'm just kidding on all that stuff, except the Tampa, Florida, and the beach. Click. 66-9-year-old tend to prefer older presidents than the 18 to 29. The most popular age for president is 50s for both age groups. However, the older age group was much more likely the younger to say that the best age for president is the 60s. The 60 to 69-year-old was much less likely than 18-year-olds to say the best. I think they put it too many times. I think by at some point you can start saying younger and the older. And I think they put way too much. And like, you're not going to make me happy if you put this much. The book. Somebody trying to show off how smart they are. Anybody, y'all done calculus? Who's done calculus? So if you've done calculus, right, they have the answers in the back of the book. And sometimes they would explain it. Have you ever seen their work? And their work sometimes is like, what the heck did they do all that for? Because they're just trying to show off. all this person trying to do is show off. Click, click, click. Notice this time here, they put them, there's the teens and there's the tweens. Again, we could talk about the heights of each one of those, yada, yada, yada. I'm tired of wasting time on this. Oh, here's the teens and here's the tweens. And here's the teens and here's the tweens. So this one's a side by side and this one's like two separate if you want to. It's separated. Just kind of understand how to do this stuff. It's really hard to do this with a pie chart. Click, 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 click. Misleading graphs. Let's talk about those for just a little bit, right? Resist the temptation to make your graphs look pretty. Resist it. Just concrete evidence. Pictures, 3D, when creating, it tends to mislead us. Our eyes are asphyxiated to the area. And if the area is a whole lot bigger than this one, then we think that's a whole lot more. But the height may not really be that much more. Okay, let me just show you several examples. Just don't do this. Just be careful about your bars. You want your bars equal width. You don't want one of them wider and one of them narrower. You want them equal width. If you're going to use a picture, make sure they're all pictures, but make sure they're correct. I'm going to show you a couple that are wrong on that. Numbers that don't add up. I took this one off of, I guess it was Fox. 63, 60, and 70. What the heck are they doing? Makes no sense whatsoever. I don't think 60, 63, and 70 is like, makes you wonder where they even got their information from. Misleading axes. I'm okay here, even though they started at 44. This is a time series plot. 44, 45, 46, 47. It's okay that they broke that up because it's not really misleading, but it went from March to May and then from May to July. And then from July to September, September to November, November to January, January to March. It's just not consistent. It's not wrong. It's just not consistent. Just be careful about graphs. That's all we're telling you, right? Here's one here. They're not wrong. We're just asphyxiated to the larger dude right here. This is a 3 and this is a 1. But it looks like I could put about 20 of these cats in here. Same way over there. Michael is twice more than Sonia, but it's just that it looks more than twice. It's just our eyes are fixated to the area. Just be careful. It's not wrong. It's just, Dairy cows. You'll start to see a theme here. Wait till you see my tests. Tests for Cheez-Its. 1970, 80, 90, 2000. That's good. 1 pail, 19. Okay. 2 pails, 32. What the heck? Why are you drawing pails? 3 pails, 52. There's 3 times 19 is not 52. 1, 2, 3, 4, 5 pails, 88. What the heck? Right? It's just, we're asphyxiated to it. This looks like it's 5 times as many pails as here, and it's not 5 times as many. Just be careful. Oh, the Macintosh. Yeah. Macintosh is what 320, 330, 340, 350. Let me also talk about that, right? I don't have the data. So if you said the Macintosh is at 340, they're going to give you credit. If you said 350, you're going to give you credit. If you said 360, they'd probably give you credit. If you said 400, they will not give you credit. And if you said 300, they will not give you credit. Y'all okay with what I'm saying? They're not. Well, how do I know? Well, if they don't know, if you don't know, they probably don't know. Just don't lie. Don't lie. I keep blocking you off. I'm sorry. Misleading baseline. That's the most common one that they'll do. Okay. This starts off at 94. This is 96. 98, 100. 102, 104. So this bad boy right here is somewhere like 103, 104, and this bad boy right here is 90, and it looks like it's twice as high, and it's nowhere close to twice as high. Misleading. Misleading. That bar looks a whole lot taller than that bar. I got a better example of that. This was on the news one day. I copied it. Whoop. Sorry. Oh, I got to go here. This leads up to it. Get there, get there, get there, get there. Boy, we're so fast. Goodness gracious. Get off your computers. I'm kidding. There's a picture of the graph. Your giggle's not 1/8 of what she gets giggled. So, speak.
Time for months before anybody else had any ads on in the state in this election season. Look at the number of ads that Newt Gingrich and the PAC supporting Newt Gingrich have run in Florida in a span of 2 weeks ahead of primary day. 210 ads total. Now look at the number that Mitt Romney and the PAC supporting him have run. Not to scale, right? Why even bother making a graph?
She's got a point.
I'm sorry. It looks like that's like what? A third of 12,000? Yeah, not to scale. Mitt Romney at 12,768. So yeah, he's winning. The Democrat, the worst bar graph in the history of cable news. That's astonishing. Anyway, the Democratic Party actually circulated this comparative figure today without the worst graph ever to give
Without
their
it.
spin on how Mitt Romney has put together this win in Florida.
Okay. I just get tickled over her getting tickled. They're going to ask you something like, how could this be misleading? And don't lie. Just don't lie. The satellite is 4 or 5 or 6 times the area of the other satellite when really it's only this much taller. It's unequal width. I mean, there's just a ton of answers you could put right here. Don't lie. It's misleading because the total areas of the satellite make it look like the number of satellites owned by U.S. is dozens times larger. No, dozens, squishy words. Times larger than the number of satellites owned by China or the U.S. or the U.K. Sorry, and at least 10 times larger. Okay, y'all okay with all that stuff? Just don't lie. Don't lie. I don't think they're going to ask much about a misleading because it's too open-ended. There are wrong answers, but there's a whole bunch. I almost said the wrong thing. Bunch. Almost said butt ton. I guess it's okay to say butt ton. Of right answers. Just don't put the wrong one. Clicky click, 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 click. Oh, I'm putting all these stupid things over here. Okay, whatever. So explain why this could be deceptive. It doesn't start at 0. I mean, China and UK look like they don't have any satellites. That's bad. That's just not good. And it looks like US has taken over whatever. That's the satellites. Same data. So explain why it could be deceptive. The graph does not start at 0. It's missing information. It looks like China and UK don't have any satellites. Where do I stop? I don't know. You're trying to hit the rubric. The bar chart is misleading. You don't have to start off with the bar chart is we know it's misleading. You can just say because. Y'all good with that? You don't have to do the English or the history. Answer the question within the question. You don't have to do that. That's misleading. I know it's misleading. You don't have to tell me it's misleading. Explain what the center of the graph is. The center of the graph is. You haven't answered anything yet. 27. There you go. Got it. All right, my question is to you, can you make and interpret a frequency and a relative frequency chart? Can you make and interpret a bar chart and or a pie chart? Can you compare distributions of categorical data? And can you identify what makes something a misleading graph? Good enough with all those 4 things? Easy lesson. You got homework tonight. It's 1B. So it should already be posted on Achieve. You cats that need Achieve, you have to go to Clever. When you go into Clever, you'll see Achieve app. Okay. Not for Achieve. You need to get one for Classroom, but I'll get that to you guys. Oop. And then I got to go here.